Welcome back to my channel. This video is a continuation of data handling chapter. In this video we'll be discussing about what is meant by expression, the different types of expression and how to evaluate an arithmetic expression, and also about the different types of modules available in Python. And we are moving to an expression. An expression has something called atom and operators. What is atom is, it can be an identifier, a literal, a string, list, tuple or set, dictionaries, whatever is there, all are called as atom. Both are, if we are joining the operators and atoms together, it forms an expression. A compound expression is the one which contains both the all the operators in the same expression. Here we have, if an expression is having the arithmetic operators, then we say it as an arithmetic expression. Then relational operator lesser than, greater than, we say it as a relational expression, and logical operators we say and, or, and not, we call it as a logical expression. And string expression are nothing but a string added with another string, which is called string concatenation. Both the string joined together is a string expression, and this is another form of string expression, a string multiplied with a number. We'll be seeing more with this in string manipulation video. And here, if it is Python into 2, then Python will be repeated twice. This is also called as a replication operator, and this is called as a concatenation operator, plus and multiplication. And the next one is evaluation of an arithmetic expression. And here, what you need to know is something called implicit conversion. Some conversions can be performed by the compiler by itself when there are intermixed data types. Intermixed data types in the sense, if it is int, float, or some other data type combined together in the same expression, then what will be the final result of the expression, whether it is of type int or float, that will be decided. If it is decided by the compiler itself, then it is called as implicit type conversion. And this conversion is done by giving a type promotion, by giving a promotion to the largest operand. For example, if you are having int and float both in the same expression, if I am having 5 plus 4.0, 4.0 is having more precision, and that is how the result of the integer and the floating point number will be floating point number itself. If it is 5 plus 4.0, then it is 9.0. Here we are just seeing some examples of the type conversion, like ch is equal to 5, it is an integer, and I is equal to 2, we have another integer, and db and ft is having some floating point numbers, and a is equal to ch plus I divided by db. Here int and int are added together and divided by a floating point number. The result will also be a floating point number. If we are printing the value of a, we can see that. And here also we have some floating point number intermixed with the integer, so the result will be, for sure, it is a floating point number. Evaluating a relational expression, this we have already seen. If it is a lesser than b lesser than c, then we have to consider it as a lesser than b and b lesser than c. Suppose it is p greater than q lesser than y, then it is p greater than q and q lesser than y. I think this is also understood. And we have evaluation of the logical expressions, and here an arithmetic expression is there. This is an example which I wanted to show you. Here 25 by 5 is there. This is a compound expression because it is having a relational operator, logical operator put together. Here what should be given a more precedence, that we are going to discuss now. 25 by 5 is 5, it will be evaluated, and 5, plus 20 by 10 will be there. 20 by 10 will be evaluated first, which is 20 by 10 is 2. 2 plus 2.0 is 4.0. In this case, 5 or 4.0 will be there, and afterwards OR operator will be performed. The truth value of 5 is true, because it is not 0, then the truth value is true. If the OR operator functions as if any one is true itself, the value is true. The first value itself is becoming true, that is why we are getting the value of the whole expression as 5 itself. And we have precedence of logical operators among themselves is not, and or. And if this is an expression a or b and not c, here I have given the brackets in order to make you understand which is having the highest precedence among this. Even if the brackets are not given in this expression, it performs in the same way. Not operator will be given the higher priority, and that is how not c will be performed first, and that value will be ANDed with b, and the whole value will be ORed with a. And if p and q are not c, this is another expression I have given without the brackets, it performs as I have given in this particular expression. Suppose if I am giving, if an expression is having AND, OR and NOT, and it is having a parenthesis which is with and not C here, here how it performs is not C will be performed and P and Q will be done, and afterwards the value will be odd together. And the next thing is there are some sample expressions I have just given for you to work out. Let me just explain one of the expressions. Let me take this expression, not operator. Here the not operator, if you see the precedence, the boolean not is having is having more precedence than and or, and before all the boolean operator is being taken into account, we have to see the relational operators first. If you see this expression, here 8 less than 18 will be first done, and then it will be noted to get the value. If 8 is lesser than 18, yes, it is true, 8 is lesser than 18, then it will result in not of true, which is false. Then we have 5 lesser than 10 here. Yes, 5 is lesser than 10, so it results in true. Here 10 is lesser than 5, it results in false. So here true and false, or true and false. Then this will be again evaluated to here true and false will result in false, and here again true and false will result in false, false or false, and it will also result in false. And that is how the evaluation of the expression will be done. Let us move on to the next slide. Here we are going to discuss about the typecasting. Explicit conversion of an operand to a specific type is called as typecasting. We are converting one operand of one type into another type explicitly. If the user himself is converting from one type to another type, then it is called as explicit conversion. Here int of 7.8, int is a function which is being given a value inside the function. 7.8 will become an integer, which is a result. Float of 7, we are trying to convert 7 into a floating point number, and that is how we are getting 7.0. Float, in the bracket we have a string. The string must be a string must contain only the group of numbers. If it is a sequence of numbers, only then this function will be performed correctly. Suppose if you are giving inside the string, if you are having some alphabets also, then it is going to result in an error. Otherwise, if it is only numbers, then the numbers will be converted into a floating point number. Int also, in the same way, if you are giving some number which is a string which is containing only a sequence of numbers, then the string will be converted into integer. Here we have a complex number 23.54. When it is converted into a complex number, it will be added up with plus 0j. If I am having 23.7j alone, it will be just displayed as 23.7j itself. And also the complex function can also be used with two parameters. If I am giving 3,5, then it will be 3 plus 5j. 3 will be the real part and 5 will become the imaginary part. If I want any number to be converted or anything to be converted into a string, I can give it as str of 4, which will be converted into a string, and str of 0034, which is a octal number. The number will, if it is converted into a string, the number will be first converted into an integer, and that number will be converted into a string. And here we have an hexadecimal number because it is represented as 0x23. That hexadecimal number will be converted into an integer, and that number will be converted again to a string, which is 35. And we have str function. If I am having in the str function I am having an octal number, then it is resulting in a string itself, because the input I am giving itself is a string. I have stored s as a string, so that is how the value is also returning as a string. If you are giving any other number, then whatever number is being given, that number will be converted into a decimal number, and the number will be returned as a string number. And here, if you have given a string itself inside the string function, then the result will also be a string. There is a function called bin, which is going to return a binary number of whatever value given inside. If I want the binary value of the octal number 24, then if I am giving bin of yes, it is going to throw you an error. Instead, we have to convert it into an integer number, and then we have to pass it on to the binary function. In this case, int function will be having the value of a string which is holding an octal number. In order to specify it as an octal number, you have to give one more parameter, which is 8. If these two parameters are given, this s is nothing but a string which is an octal number, and string containing an octal number, and we have another parameter which is going to tell this function what is the number is about, what is the base of this number. It is of octal number, that is why we have 8, and this integer number will be again passed as a parameter to the binary function, which is going to convert it into a binary number and display the result. The last one which we are going to see is a module, Python module. There are some modules which is discussed in this chapter: math module, random and statistics module. In the first of all, you need to know what is meant by module itself. Module is a file which is going to contain some functions. In order to use those functionalities, what you have to do is you need to make use of a keyword called import. If you have written import math, then whatever functionalities available in the math module can be used. Import random and import statistics can also be used in order to use its own functionalities. Let us see what is available in the math module. Here an import math is being given, and the first function we are going to see is CL. Here if CL is being given and 1 is being given as input, a parameter or argument passed to this function, 1 will be the result. CL is nothing but the nearest greatest number. If an integer number itself is given, it will be the result. But if a floating point number is given, which is let us start with a positive number 1.5. 1.5's nearest to highest value is 2, but minus 1.5 if it is given, it will be minus 1, because the highest value is here minus 1 and not minus 2. Minus 1 is greater than minus 2. And then math dot square root is the next function. SQRT means it is square root. Square root of 45 is being found out, and that will be the result. Square root of 64.0, 8.0 will be the result. And logarithmic function can be used using math dot log. Whatever value is being given inside the log function, the logarithmic value will be found, and that will be the result. And here if it is base 2, we can also supply it using comma 2. So these are the two numbers which are passed to the function called log. Here first number is, we need to find the logarithmic value of 2344 of base 2, and that is why we have an option of also passing 2 as the base, which is the second parameter of the function log. And the next is, if a negative number is given, then it is going to return a domain error, and also if 0 is being given, it is also going to result in a domain error. And for log 10, for the logarithmic to the base 10, there is a separate function called log10 itself. You can either have a comma 10 here to be passed, or directly you can make use of log10, which is also a function available. And 33 is a value for which we need to find log10 value, and using math.log10 of the whatever value is being given, the logarithmic value will be the result. And absolute value, it is FABS. Any number which is being passed for to the function FABS will result in a positive number. If it is a negative or positive number, whatever may be, it is going to result in a positive number. And math.float is the nearest to smallest value, minus 3.4. In the case of negative number, minus 4 is going to be the smallest value, and 3.4 in the case we will be having 3 as the smallest value. And exp is a function which is e power any value, e power 2 if it is there. If then math.exp of 2.0 will be the exact Python expression. And POW is a function which doesn't need any math dot to be used in front of it. POW of 3, 2 is 3 power 2, which is 9. And POW of 5, 3.4 will be 237.95, and this will be the result. If you need to find the sine value, then it is math.sine. Cos value, it is math.cos. And tan, math.tan. If you need to convert a number into radians into degrees of, in the bracket you can give the radians value, and into the radians means that whatever degree value is being given will be converted into radians. And this will be a question which may be asked in your exam. Write a corresponding Python expression. By this time, whatever expression, a mathematical expression is given to you, you should be able to convert it into a equivalent Python expression using the math functionalities, the math module. And this is a modulus, which we call modulus of B. And here we need to make use of absolute value, FABS, which is a function for finding the absolute value. Plus for square root, we have math.square root. Square root of the whole expression is being done. That is why we are opening the bracket and closing the bracket, within which we will be writing the equivalent Python expression for this expression. And for this, for a power 3 we can either use a asterisk 3, or otherwise POW function is also there which can be used, minus 4b, which is nothing but 4 into b, and again one multiplication symbol. Here asterisk is used to denote the multiplication, and a plus c the whole power 5. So POW function will be having a plus c comma 5 divided by the whole expression 2 into here cos x math dot cos of x plus math dot tan of x plus math dot exp of x, exp of 2, because it is e power 2, it is exp of 2. The next module is random module. Here we have a function called random, and rand int is another function, and rand range itself is having 3 types of arguments which can be passed. First, let us see what is random function. Now, if you need to display any random number, a number which is generated by chance randomly, we need to make use of random module, and inside random module we have a function called random which displays only the floating point numbers, which ranges from 0.0 to a number which is lesser than 1.0, which is 0.999. It goes on like that. And rand int a comma b will result in a number between a and b. Here b will not be included. It is between a, it starts with a and ends with b minus 1. And here rand range rand int of a comma b denotes any number between a and b. So both a and b will also be considered, will be the result of rand int of a comma b. Suppose it is rand int 4 comma 7, then 4, 5, 6 and 7, or any one of these 4 numbers will be the a random number by chance. Rand range will be having 3 types of arguments. One is start, stop and step, another one is stop alone, and another one is start comma stop. Let us see this with an example. So because we are using random module, we need to import random before using. Print random dot random means from the random module we are using the functionality called random, which is going to randomly display any number, generate any number between 0.0 to 0.999, and here we have a number 0.4. If you need to specify the maximum upper limit and the lower limit also, you can specify in this manner. You can multiply the maximum number minus the smaller number, the minimum number, plus the minimum number itself. Suppose if this whole expression itself is becoming 0, because random dot random can also display the minimum number which is 0. If whole expression is becoming 0 also, the minimum number 15 will be the result. Even if the maximum number is being displayed, which is 0.999 into, because it is subtracted with the maximum number minus minimum number and added up with the minimum number, it will be between 35 and 15 and 35. And that is how a random number will be generated. If it is more than 1, you wanted to generate more than 0.999, then you can make use of this particular method. And here rand int is another function which we have already seen. If both a and b will be considered. Here 14 and 20 are there. Both the from the number 14 to 20 will be considered, and any number between that will be the result. So here also we have one more chance. So here 16 was the result, and then the next case we had 15. And random dot rand range of 45. Here we have 22, which means that here if only one argument is being given, it means this is a stop value, and the stop value will be until 44 only, and so from 0 to 44 any number will be displayed as the result. If it is 2 argument passed to the rand range function, then this will be the start value, and the number before this will be the stop value. From the 30 to 44, any number between that will be the result. Here if 3 values are given, first value will be the starting value, and next value will be the stop value which is before this number. So 44 will be the stop value, and then 3 will be the step value. So the all possible numbers are 30, 33, 36, 39. It goes on like that, and it stops before 45. And that is how we will be getting any particular number with the step value 3 will be the result. The statistics module is the last module which I am going to discuss, and here we have some functionalities called mean, median and mode. Mean will be the average of any numbers given inside a particular list. A which is being supplied to this function mean, which is inside the module statistics, will be a list. It can be a list or a tuple, but it has to have some set of numbers, and these numbers for which it is being supplied, for it, the average will be found out, and that will be the result of mean. Median will be the middle number, or the values which are being passed to this particular function will be taken into account, and with that whatever middle value is there, that will be the result of median. And here mode will be the repeated values. Mode of A will be whatever values which are supplied to this mode function. From those values, whatever value which is repeating, that value will be the mode value of A. And for whatever module you are using it, don't forget to import that module, and also the module will be there which is given before whatever functionalities you are using it. Statistics.mean, statistics.median and statistics.mode must be used in order to make use of the function which is there available inside the statistics. And we have come to the end of the data handling chapter. Thank you for watching this video. If you really like the video, please subscribe to my channel, like the video, and please share to your friends too. Thank you.